Hi, welcome to this video. In this video I'm going to demonstrate the functionality of the JAL INA3221 library for the PIC microcontroller, which is programmed with the JAL programming language. So what will be the contents of this video? First, a short introduction. Then a description of the INA3221 device. Then I will explain something about the module that you can purchase, because if you want to use the device in the right way, you also have to purchase the right module. Then something about the functionality provided by the JAL library, the schematic diagram that I'm using for this demonstration, then the demonstration itself, and at the end of this video you can find some references. So, something about this device. The INA3221 is a triple channel shunt and bus voltage monitor. It's quite a mouthful. But next to measuring voltages and currents, it also has an alerting and a warning function. And the JAL library provides all the functionality that are supported by this device. And you can purchase the device as a module, and it makes life easier if you want to use it. In this demonstration I will show the operation of the library, and I'm using a serial interface to the PC. So something about this INA3221. So the supply voltage is 2.7 to 5.5 volts. It senses bus voltages from 0 volt to 26 volts. So on the left you can see what the definition of the bus voltage is. It reports shunt and bus voltages, and shunt voltage is a voltage over a resistor. It supports 3 independent channels. It has a high accuracy, and it has programmable alert and warning outputs. And it communicates via an I2C interface at a maximum clock frequency of 400 kHz. And you can change the I2C address by changing the assignment of pin A0. You can connect it to ground, or connect it to the supply voltage, or to one of the I2C lines. If you look at the typical module connection, it looks as follows. So you can measure up to 3 channels independently. The power plus in this example is the bus voltage, so it's the voltage at the top of the resistor, and the voltage over the R100 resistor is the shunt voltage, and the current is measured via this shunt resistor, and R100 means 0.1 ohm. The bus voltage is measured in millivolts, and the shunt voltage is measured in microvolts. And if you have the shunt voltage and the shunt resistor, you can calculate the current, which is shunt voltage divided by the resistor value, and this is in microamps. So if you want to use this device, you can purchase 2 types of model. The left one is the not preferred one, and that's because at the bottom you see the V in plus, and then the connection on the right there is to ground, and this makes the module this pin input less dependable. You better purchase a module which is shown on the right, where the V in plus and the V in minus are independent of each other and not connected to ground, so you have more flexibility. And I'm using the module on the right in this video because I want to demonstrate the use of these independent inputs. So something about the library. There are 2 versions of this library. In fact, there's one version, but you can compile it either to represent values as a float, or use the word an SD word as to represent the values. And the reason for that is that if you're using float, the library becomes larger and slower. And the main functions are: you can initialize the library. Of course, you don't have to initialize the device, but it sets, for example, the current to 1.0 ohm. It also sets the I2C address. But you can always change I2C address, and you can always change the shunt resistors. You can check for the manufacturer ID and the die ID. It will measure bus voltage, shunt voltage and current. you can enable and disable channels, and you can set critical alerts and warning alerts for each channel. And you can also set the power of valid upper limits and lower limits, and there are a lot of other parameters that you can set using the library, like the number of samples, the conversion time, operating mode, etc. And for this demonstration I'm using the following setup. So on the left you see the PIC microcontroller and the connection to the serial interface, and in the module that you see on the right there are three types of connections. So channel 1 is connected to 3.3 volts with this load resistor of 33 ohms. Channel 2 has the same type of connection but has a 6 volt input. And channel 3 is used different. There you have a battery which is connected to the V- input, and that means that the current through channel 3 is negative, and that's only possible if you're using the right module. So in this demonstration I'm using two different bus voltages and I'm using a battery, and all are independently and all have a load of 33 ohms. So the bus voltage is 3.3 and 6 volt, and it will give a positive current. But as you saw in the schematic diagram, the battery is connected to the V-, so it will give a negative current. The bus voltages, the shunt and the currents are shown for all channels and updated every second, and I'm using a serial interface. First I will demonstrate using the library with the Word and SD version, meaning that the values are represented in millivolts, microvolts and microamps. And then also in the second demo we'll use the float representation, but it's the same functionality, only different representation. I will set the show warning alert on channel 2 when the shunt voltage is above 80.5 millivolts, which means 185 milliamps. I will increase the voltage on channel 2 to show that the alert will be active. And I will set the critical alert on channel 3 when the shunt voltage is above -3 millivolts, which means 30 milliamps. But because it's negative, that means that the alert will go off when the current is too low. So in this first demo I'm going to show the version which uses Word and SD Word, so no floats. So I will reset the chip, okay, and press reset to prevent the update. So what you will see here is I'm setting a shunt warning alert on channel 2, which is 18.5 millivolts, that equals 185 milliamps. And I'm setting a shunt voltage critical alert on channel 3, which is negative, a minus. So it's 3 millivolts, which equals 30 milliamps. So you see the bus voltage on channel 1 is 3.36 volts, the shunt voltage and the current is about 95 milliamps. Then the bus voltage on channel 2 is a little bit more than 6 volts. It has 180 milliamps, and you can see the lever here is 185, so if I increase the voltage I will get a warning alert. And on channel 3 this is the battery voltage, and you see the current of 33 milliamps. And later I will remove the battery voltage and it will drop, and then the alert will go off because the current is getting lower than expected. So let's continue doing these measurements. So I will first increase the voltage on channel 2, and now you see I get a warning alert. So I will reset. And why do I get a warning alert? Because the current is 192 milliamps, which is more than the 185 that I just set up. So I will continue and I will remove the battery, and then I get a critical alert. Also pause this, because of course there is no current flowing. So if I now connect the battery again and lower the voltage on channel 2, both the alerts are gone. Now I will load, let's say, the version which uses floats, and I will do the same thing. I first reprogram my microcontroller. I will clear the screen, and we get the same functionality. So here you see the same, let's say, warning alerts, critical alerts, and the same voltages only represented as floats. And I will increase the voltage on channel 2, I get the warning alert. I will remove the battery, I get the critical alert. If I connect the battery and lower the voltage, both alerts are gone. So, that was the demo. If you want to know more about JAL or about the JAL programming language, you can visit the JAL website. There you can download all the packages, all the libraries, the samples and the compiler. And if you want to get started with JAL, you can have a look at the video. If you have questions on how to use JAL, there's a very good tutorial that you can download, or you can visit the JALDIS Google group and post your question. And for reporting bugs in JAL, the libraries, compiler, or you have specific requests, you can visit the JAL Google group. And JAL itself can also be downloaded, all the sources and the compiler, and also you can find it on GitHub. I hope you liked this video, and thanks for watching.